Hello, class 12th students. We are learning the integrations and the chapter 7. We are doing the exercise 7.3. You have seen my previous video that up to we have done the question number 15. Now, we start with the question number 16. We want to find out the integration of this part in integrand 10 raised to 4x dx. We don't have formula. Okay. So I can write down this one in this way in terms of 210 square x are there. You know that here we can say that 10 square x into 10 square x into 10 square x. Since you know that very well that a raised to 4 something can be written as a2 plus 2, can we, you can say this is a square into a square. Now dx is also here. See, again you know this formula also that tan square a equal to sec square a minus 1. We apply this formula, take the method formula here. We are getting sec square x minus 1 tan square x dx. Now, separate the terms. Open the, you can means the open the bracket. We are getting sec square x tan square x minus integration of this dx is also here tan square x dx. Now, in the part 1, it's the easy one is that, and in this part 1 integration of this part, okay, I take here this tan x equal to t, put tan x equal to t. So if tan x equal to t, taking a differentiation, you are getting sec square x dx equal to dt. For the second part, we will break it. Now, see how we will put the value and solving this question. Now, we are putting this value tan square x equal to t, and so you become this integration becomes t times t square uh, dt. And second part tan square x dx, this part integration minus, I will write down here this one in a two parts. One is sec square x minus 1 dx. Okay. Now we take the integration. So what we are getting, or separate the terms basically. Just separate the terms. T square dt minus, separate this one. We are getting integration of sec square x dx minus minus plus integration of dx. T square taking the integrations, t cube by 3 minus sec square x integration will be, you know, tan x, and dx integration, you know, x plus some constant c. Now put the value of t, you will get the answer t equal to tan x. So just you want to put the value of t here, you will get the answer. T will be here tan x cube divided by 3 minus tan x plus x plus c. This is the answer of this question number 15. Now we want to do the next question, question number 16. Okay, question number 16 we have done, no doubt. Now we want to do this question number 17. See this question. I'm interested to find out only the integration of this question. Number 17. Here, how can we proceed? See, in this, we have a denominator, we have a sine square, cos square x, and numerator, we have a sine cube x and cos cube x. Okay, let me separate the terms. If I separate the terms are there, just separate the terms. If we separate the terms, what we are getting? Sine cube x can be written as sine square x cos square x dx plus integration cos cube x divided by sine square x cos square x dx. I will separate that. You see this sine qx is in the numerator and sine square x dx. So we taking the sine square x upper side. So we are getting sine x, and this cos square x can be written as two parts: cos x into cos x dx plus this, you say this cos cube x, and this is denominator we have a cos square x. So this cos cube x and cos square x are there, but cancel out. We are getting the numerator cos x divided by sin x, and take the sin x into sin x dx. So you know sin x upon cos x equal to tan x, and 1 upon cos x means sec x. This becomes cot x, or the 1 upon sin x becomes cosec x dx. Now, we know this is the direct formula. Now we know these formulas are there, direct formulas are there to get the answer. That integration of tan x sec x dx. This is the direct formula of sec x. You remember. Plus, see this one. Integration of cot x cosec x dx. This is the direct formula of minus cosec x. And so instead of writing this plus sign, we better be write on the minus cosec x plus some constant c. This is the answer. Now, after this question number 17, we are interested to do the question number, next question 18. See this question number 18, what it says basically. It says cos 2x plus 2 sine square x divided by cos square x. And we are interested to find out the integration of this part. See, in this, first we want to remove the denominators. And how can we remove the denominators? We have in the cos 2x terms are there. I will replace this cos 2x terms by some formula. Say, since you know cos 2a equal to 1 minus 2 sine square a. Use this trigonometric formula here. The integration becomes cos 2x becomes here 1 minus 2 sine square x plus 2 sine square x divided by cos square x dx. And you solve this one. This, you see this minus 2 sine square x, this plus 2 sine square x will be cancelled out. And what we have left in the numerator, only 1. 1 upon cos square x dx. That will be, you can say, nothing. This is a, you can say, sec square x dx. If you do the integration of this part, you are getting, this is the integration of tan x plus c. This is the answer. Now, Question number 19. You see this, the trigonometric function is given in the denominator. This trigonometric function is given in the denominator. 1 upon sin x cos cube x. So what should we do here? Because the cos cube x, we don't want the values in the denominator basically. So we have made this tan x basically, so that divide numerator. Want to make the tan x, so need the cos numerator and denominator by cos 4x. So what we are getting after doing this one? This becomes sec raised to 4x divided by this one divided by cos 4x tan x dx. So sec 4x can be written as integration of sec square x into sec square x dx upon tan x. This can be written as, I will say that here, 1 plus tan square x into sec square x dx divided by tan x. Now, in this question, put tan x equal to t. So taking differentiation, you are getting sec square x dx equal to dt. So this integration becomes now this. This integration now becomes, you can say, 1 plus tan x means t square sec square x dx, no, not double dx, sec square x dx will be equal to, you see, dt. In the denominator, we have a tan x, that becomes t. Simplify this one, you are getting, or you mean separate the terms in the numerator, 1 by t dt plus t times dt. Taking integration, you are getting, this is a log t plus t square by 2 plus some constant c. Put the value of t, log of mod tan x plus tan square x by 2 plus some constant c. This is the end of this is the answer of this question. Now, we will do the next question. Question number 20. Question number 20 says cos 2x cos x plus sin x whole square. So in this question is given to you, and you have want to do the integration. Here in the numerator, denominator, we have a cos x plus sin x. We know that cos 2x can be factorized in this way. Let's say this one, you know this formula, cos 2a, since you know this formula, equal to what? Cos square a minus sin square a. So we know these formulas are there. Apply this formula here. So this integration becomes cos square 2x minus sin square 2x divided by cos x plus sin x whole square dx. Now, you know this formula also. A square minus b square equal to A minus B, A plus B. We can use this formula. So this becomes what? Cos 2x is a A and sin 2x is a B. So so it becomes not cos 2x. I have done some mistake. This is not cos 2x. This becomes cos x. This is sin x. Cos square x minus sin square x. So this becomes cos x minus sin x. Since you have this 2a equal to 2x, so a will be equal to what? X, not the 2x. So it is cos x plus sin x divided by cos x plus sin x whole square dx. Now you see this cos x plus sin x terms is common. This one factor and this is square factors are there. So one factor will be cancelled out. So it becomes cos x minus sin x, and now you can say this is cos x plus sin x dx. Now here this question is now very easy. And now we put the numerators as a t and solve these questions. But you have done already this type of question already, that cos x plus sin x equal to t, taking differentiation, minus sin x plus cos x dx equal to dt. So now put as integrations, simplify the integration. Simple question of integrations that already we have done. So you know that how can you solve this question after that. Let me do it again. This you see cos x minus sin x dx equal to dt. So numerator becomes only dt. And denominators, we have put the value t. Solve this integration. You see this one is a log t plus some constant c. Put the value of log t here. Log of mod cos x plus sin x plus some constant c. And this is the answer. Now, I will do the next question. After this question number 20. Okay, fine. And now I would like to do this question number 21. We want to find out the integration is there. Sin inverse cos x dx. Okay, fine. Say the angle of this function. So in this angle, we have a cos x function of sin inverse. So we know the properties are there. We say that here properties are this one, that sin inverse x equal plus cos inverse x equal to pi by 2. Since we know this property, we will use this property. So the sin inverse cos 2x cos x can be written as this integration pi by 2 minus cos inverse cos x dx. Since now you know also that cos inverse cos x equal to x. So this will be equal to what? Integration of pi by 2 minus x dx. Separate the terms. If you separate the terms, what you are getting? Pi by 2 dx. Pi by 2 is a constant minus x dx. Taking the integration, pi by 2 into x minus x square by 2 plus some constant c. This is the answer. Now, question number 22. In question number 22, you see this one, denominators are given to you. Okay, sorry. These denominators are given to you, and I have to find out the value. So these denominators are given, and how can I, if I expand this function denominators, it cannot solve the purpose because all the formulas lies only in the numerator sides are there. So I have to make it 10 functions. Someone thinks that cannot be. So I will do one thing here, that I will add in this question something that is, you can say like this one, sine x minus a, sine x minus b, right? So this integration becomes basically, you can say, I will like to add, you see this one, sine x minus a, sine x minus b. Okay, fine. You see this one, sine x minus a minus x minus b. If you simplify this one, what you are getting? Sine x minus a, since we are saying that here minus a minus x plus b. So this will be equal to, you can say, sine of b minus a. So I'm writing here, multiplying these terms, numerator and denominators, we are getting 1 upon sine b minus a into, you can say, sine yes sine x minus a minus x minus b divided by cos x minus a cos x minus b. See, in these questions, I just put these two values. These two values are same value. The value of this one and this one are same thing. And when these two things are same, so I can just multiply the numerator and denominator by the same value. So basically, the function will not change because we are multiplying and dividing by the same factor in a function. So now, 1 upon sine b minus a. See, there's no variable. X is the variable, so it can be as a constant, so taken outside. And now we apply here the formula sine a minus b. We apply the formula of sine a minus b. Sine a minus b formula says sine a cos b minus cos a sine b whole divided by cos x minus a cos x minus b. Since what formula I am using here? Sine a minus b formula. Sine a, I am writing a formula again to you. Sine a minus b means sine a cos b minus cos a sine b. Okay. Now I would like to do in this integration. This is the integration. Basically, we are doing the integration. So if we have an integration sign also here, integration, and this we have a dx. So inside the integration, integrants, I will separate the terms. If I will separate the terms, so what we are getting? We see here 1 upon sine b minus a constant, and we are taking the integration. We are separating the terms. So terms will be separated. You say sine x minus a cos x minus b, x minus a cos x minus b divided by cos x minus a cos x minus b minus sign cos x minus a sin x minus b divided by cos x minus a cos x minus b, and we have this dx. Now, so these constant terms are there. We have a 1 upon sine b minus a constant is here, no doubt, taken outside. Now, say this first term of integration. Sine x minus a, this cos x minus b and this cos x minus b will be cancelled out. And now we have only sine x minus a upon cos x minus b. So this becomes, this integration is also here, no doubt, tan of x minus a. Say in the second terms, cos x minus a, cos x minus b cancel out. Sin x minus b divided by cos x minus b become the tan x minus b minus tan x minus b, bracket closed, and now we are doing the integration. Now we can do the integration directly. So far you have learned so much that I think you are able to do the integration directly. So we say that here 1 upon sine b minus a. This integration we are doing this terms and this term. First term becomes you say sec square x minus a, and the second term becomes not the tan x. Okay. Tan x minus 1 has a integration log of, we are doing these integrations, so it becomes log of sec x minus a mod minus log of sec x minus b mod plus some constant c. So we are combining these log terms, since you know log a minus log b will be equal to log a upon b. So I am using these terms to combine these two terms. It becomes 1 upon sine b minus a, constant is here, and these two log terms will be combined, log of sec x minus a divided by sec x minus b, and taking the plus some constant c. This is the answer of this question. Now we will do the next question. (22) we have done. Now we do the question number 23. In question number 23, these 4 options are given to you for the question. That which one is right? They are asking sin square x minus cos square x divided by this sin square x cos square x dx is equal to what? So what should I have to do? I will separate the terms. If I will separate the terms, then what I am getting? We are getting sin square x. Let's say you are getting sin square x divided by sin square x cos square x minus integration cos square x dx divided by sin square x cos square x. See, sin square x cancel out. 1 upon cos square x becomes what? Under root sec square x dx minus, this becomes cosec square x dx. And now we know sec square 10x, this is equal to integration of 10x, direct formula. And this is the formula of minus cot x minus cot x plus some constant c. So minus minus plus, you say 10x plus cot x plus c. So the A is a right answer of this question. Now we will do this question number 24. E raised to x one plus x cos square x e raised to x x. You see what is the catch here? E raised to x x. Take it as a t. Put e raised to x into x equal to t. What you are getting? Differentiate this one. When we differentiate this one, you say e raised to x into x plus e raised to x dx equal to t. So now the integration becomes what? In the numerator becomes dt, and denominator is cos square t. That can be, you can say, sec square t dt. That will be, you can say, 10 t plus c, and put the value of 10 t. T is here. T is here. What? E raised to x into x plus some constant c. Say where 10x e raised to x plus c. This is how B is the right answer of this question. This is the end of this chapter 7.3. I hope you enjoy this exercise. Now we will come with the next exercise 7.4 in the next video. Thank you.